It's ridiculous. All right. So I'm giving you this kind of synopsis of what's going on in the GI. All right? And in the GI, obviously, we're going from stomach into the duodenum into the jejunum. I didn't draw the jejunum because obviously it looks a lot like the duodenum. But obviously the ileum, as we go along, these circular folds, right, that are really ridges of the basement membrane thrown up, right? With those fuzzy cells that have the microvilli on them. Well, those microvilli, they have enzymes on them. So when you look at that, and you look at the cell now, just one cell. Everybody see that? There's enzymes on the microvilli. And they're referred to as brush border enzymes. And the brush border enzymes are going to do the rest of digestion. They're going to do whatever they have to go back to chapter 2. Right? Chapter 2. Remember chapter 2? Yeah. Monomers, right? Or subunits and their macromolecules. So amino acids, proteins. Now we're doing opposite. Protein, amino acids. Single amino acids. Everybody hear me? And most of all of the amino acids that we absorb are absorbed via a co-transporter with sodium. Did everybody hear me? A co-transporter with sodium. So sodium is going to come in, and so is the amino acid. Same thing with sugar. So they call it a sodium glucose transport, an S-glut. That's what they call them, S-glutes. It's not influenced by insulin. It has nothing to do with insulin. It's called S-glut. Okay? Because it's sodium glut transporter. And it's a co-transporter. When sodium comes in, glucose comes in. When sodium comes in, amino acids come in. Everybody hear me? Now, fatty acids. How are we going to deal with fatty acids? Well, the fatty acids are either in triglyceride or diglyceride or monoglyceride form. Well, if you remember, any glyceride molecule, whether it be mono, di, or triglyceride, has one glycerol molecule, which is a 3-carbon compound. And then 1, 2, or 3 fatty acids attached to it, which would make it a mono, di, or triglyceride. If you guys don't know that, go back and look it up. It's in there, and it's also in chapter 2. Okay? So what's going to happen? The cell is going to take apart any triglycerides and reassemble it as it sees fit. Understand? And what's going to happen? It'll take triglycerides in, and it'll modify them and then bring them back out. And once they come out, they're referred to as chylomicrons, because those chylomicrons are going to be fatty acids that create something similar to a micelle. So you look up micelle. It's a biological term. It's when you make these small little fatty acid balls, because the tails are facing inward because there aren't enough to make a membrane. And that chylomicron coming from duodenum, jejunum, and or ileum is going where, guys? Where's that chylomicron going to go? To what? Where's it going? To the liver. Liver's going to modify. Did everybody hear me? Watch what the liver's going to do. The liver's going to put protein in it. A little protein, that's low density lipoprotein. Did everybody hear me? A low amount of protein in the chylomicron is a low density lipoprotein. A high amount of protein in the chylomicron is referred to as a high density lipoprotein. Oh my gosh. See how easy that was, guys? So if I have very few, it's low density. If I have a lot, it's high density. Did everybody hear me? High density lipoprotein, that's the good cholesterol. Low density lipoprotein, that's the bad cholesterol. High LDLs in the bloodstream will increase your risk for what? So if I have a whole bunch of these with very little protein on them, and that's an LDL, and if I get an increase in LDL, then I'm at an increased risk for what? What? Atherosclerosis, arteriosclerosis. Sclerosis. Plaquing of the arteries. Because the fats, they begin to deposit, because they're in excess, they begin to deposit in the walls of the blood vessels. And then the macrophages come in and try to remove it through saponification. They'll secrete, there'll be movement of calciums, and all of a sudden what? Now the calcium is reacting, and now it becomes like a hard substance, and it becomes a plaque. And then the macrophages call more macrophages, and they create a foam cell around the plaque, and that just makes it worse. And they call that an atheromatous plaque. Did everyone hear me? And if that plaque gets big enough, then you're going to cause occlusion. So if it's in the heart, then you're going to get angina. You get angina, you're going to come see me. I'm going to put you on a stress test. No, I'm not. At that point, you're already coming in with chest pain, and get you on a dilator, reduce cardiac performance and myocardial demand, right? And get you in there in the lab and cath up and open it up, see what's going on. Run a dye in there. See how bad is the constriction. And if necessary, if it's that bad that I can't balloon it open with angioplasty, then I'll do what? I'll replace it. I'll take a piece of the great saphenous vein, or the lesser saphenous vein. I won't take the greater, right? We'll take the lesser saphenous vein. Could take part of the greater. They make it either one. Sometimes they take both if they have to. And that's what they call what? A triple or quadruple bypass. You understand? It means they're rewiring all the blood vessels to your heart, because all your blood vessels are jacked up because all you did was what? Eat too much fat. Or you any one of us. Hey, Hispanics and African Americans, man, raise your hands, please. Raise your hands. Every single one of you has some kind of association with African American, Caribbean, or Hispanic descent. Raise your damn hand, because we are all at risk of having this. You understand? Because of all genetics, diet, lack of exercise, everything else.
You make me hate my life.
I just want you to realize that you are your worst enemy. Right? You really. If we were all enemies out there in the world, we are our worst enemies. We really are. Right?
So that's a micelle, right?
So that would be a micelle. So a micelle would just be the polar heads kind of outside, or semi-polar heads, because remember, your glycerol molecule, guys, is 3 carbons long, right? Glycerol molecule is 3 carbons long, but it's a glycerol because why? Because it's a polyalcohol. That's the name. All is alcohol. Polyalcohol. So does alcohol dissolve in water? Shit, better. Because if not, man, people be drinking what? 180, 190? Huh? Yeah, that's why it's diluted. You got wines, you got liquors, right? You got different. It's the concentration of alcohol to water, guys. It's called the proof. Huh? You got whiskeys, you got different types of whiskeys, right? So you got all kinds of stuff. So the polyalcohol is that glycerol molecule. Well, that glycerol molecule also, because it's 3 carbons, and because it has polyalcohols in it, it's the one that can attach to the fatty acid chain. Yeah? So it has the ability to hook up, because it's got 3 carbons, it can do up to 3 fatty acid chains. It will decide what it does with those fatty acid chains. Why? Because fatty acid chains could actually be fatty acid chains from components of bacteria. And so this is another reason that we handle this differently, because the micelle does not go into the bloodstream. It goes into little green finger-like structure. Little green finger-like structure. Lacteal. Micelles get to liver. Micelles get the liver via lacteals, guys. Alright? And whether it's an LDL or an HDL, this is all done by the liver. You understand? Any questions? Any questions so far? So we were comparing the wall, right? We said, well, stomach's got this really high hydrogen ion concentration because it's got chief cells that produce chymotrypsin and chymotrypsinogen and trypsinogen, and they need that hydrogen ion concentration to be high. That's done by the parietal cells, but separately they got to produce this thick mucous membrane with bicarbonate in it, and that's done by these G cells. And as the cells move up, the cells move up from the rugae, up towards the rugae from the gastric pit. So the rugae is here, the gastric pit is here. The cells migrate up, and as the cells migrate up, they slough off. See that? And that's how you prevent gastric ulceration. Anything that would reduce the thickness of this mucous membrane, medicines, like aspirin and other anti-inflammatories, non-steroidal anti-inflammatories they refer to them as. Also, steroids themselves can have an effect, because anything that, again, affects the inflammatory response in our cells would affect the production of mucus. Did everybody hear me? Anything that affects the inflammatory response in our cells, in our body, will affect the production of the mucous membrane, guys. Understand? Yes?
If we are using the hydrogen ion, what's going to happen?
Then you won't activate the enzymes and you won't digest the food. The food will just sit.
And it makes it
It'll just sit in the stomach.
makes it more hospitable for bacteria too.
But then what happens, it could, but then what, as you have slow motility. And then what happens is too, the presence of the peptide and the fatty acids that are in it, because remember, you got fat and muscle, you can't separate the two, right? I don't know of a human or any, any animal that doesn't have some percent body fat within the muscle itself that you eat that one consumes. You understand? It's just a matter of how little or how much. You understand that? So don't confuse it. I don't care what kind of beef you buying, right? It still got fat. You got me? And it still has these fatty acids, because remember, the plasma membrane of every cell is made up of fatty acids, eh? So whatever cells you eat, I don't care what it is, you could be eating plant cells, it's still made up of fatty acids, but the fatty acids of plant cells are a little different than animal. Oh. Yeah.
For the animal fat, isn't it good for us? Isn't it good with fat that was supposed to consume the animal?
Fish.
So it's not so much the form of it is, you got to be careful, because when you eat polysaturated fatty acids, right? And it takes very little in modifying it so it can be reabsorbed. When you consume polyunsaturated, right? Yeah, polyunsaturated fatty acids, you got double bonds in there. It means there are not as many hydrogens on those. Look at the difference. Go back to chapter 2 when they talk about this. The difference between saturated fatty acids, which means they get all hydrogens everywhere on the carbons. No double bonds. Unsaturated fatty acids got double bonds to it. Omega-3 and omega-6 fatty acids wind up being healthy for one to consume. Now, careful. Because the way people are consuming it now, because here's the thing, people get hyped up. Like, oh yeah, the omega-3, oh yeah, the omega-6, Let's put it in a pill. Let's concentrate, just so it's just that. What do you think, guys? Is that good or bad? Now, it's not regulated by the FDA, by the way. And then we're gonna put it out there and say, it's good for you, take it. Is it good for you? Is it really good for you? Well, one, there's no proof that it's good for you, is there? Eh? Two, the reality is if you take too much of this stuff, then what? You can have high cholesterol, exactly. You understand? It's bad. You see why? You gotta be smart. You gotta be smart consumers. We gotta know what we're buying into. Right? So now they're realizing, wait, supplements aren't so good. So we should be encouraging people not to take the omega-3 and omega-6 fatty acids. They should just be consuming it through what they eat in the meat, but nothing more. Because people start taking it in excess. Oh, I take more, it's going to be healthier for me. New studies say you're not supposed to slap your kids no more.
Too late.
Too late. Right? It says it creates deviant behavior and they become resistant to you know.
Let me tell you something. Sometimes a kid.
I'm just saying, this is what the pediatricians are saying now, that it's detrimental to the brain and overall development of the child itself. That's what they say. That's what they say. All right. So now, all right. So guys, so here's something interesting now, because here's the thing. When you eat red meat, when you eat eggs and some beans, there's this one vitamin called vitamin B12. Well, vitamin B12 in the stomach would be chopped up. Understand? So separate of the hydrogen ion concentration, the parietal cells will also produce this protein called intrinsic factor that will actually protect vitamin B12 in the stomach. Did everybody hear me? Now y'all listen to this. So vitamin B12, to be protected from digestion, has to have intrinsic factor present. You understand? So with the intrinsic factor present, it overshadows it and protects it. It then moves out of the stomach, into the duodenum, into the jejunum, into the ileum. Remember, the pH has gone back to normal. Yeah? The moment you come into the small intestine, pH is back to normal. Now you got your intrinsic factor. Now remember I told you about good old E. coli? Good old E. coli, it will take intrinsic factor off of vitamin B12, so now vitamin B12 can be absorbed by not the lymphatics, but by the blood vessels. So you got blood vessels running over the lymphatics. See, this is why I love color. I wish I had it on a damn board. That'd be nicer. But that would mean that we actually have technology in the place.
Wait, is that where
So vitamin B12 is going in the cardiovascular. So are what? All the other water-soluble vitamins. But the fat-soluble vitamins, A, D, E, and K, are going to get absorbed along with chylomicrons in the lacteal. You understand that? Chylomicrons, along with fat-soluble vitamins A, D, E, and K. And vitamin B12, they're not going via lacteals back to the liver. They're going vitamin B12, vitamin B1, all the vitamin B complexes, right? Vitamin Bs, along with vitamin C, sorbic acid, right? So all other vitamin Bs, because you got B1, B2, B3, B5, B6, right? And then you got vitamin C. We'll just put the other vitamin B, and then vitamin C. They're all going to be brought, not via lacteals to the liver. They're going back to the liver. So they're going back to the liver via, ultimately, hepatic portal. The reality is it's superior mesenteric to the hepatic portal. And the superior mesenteric is going to meet up with the splenic. And the splenic already met up with the inferior mesenteric. See? So the hepatic, ultimately this is going to hepatic portal vein to the liver. But the chylomicrons, the micelles, and the fat-soluble vitamins, they're coming via lacteals to a larger structure that's going to run back along the hepatic portal vein. And then split up and feed the liver. And then along that split up is where the gallbladder is going to get its little tributaries to pull stuff off. See that? And this is what we call enterohepatic circulation. Because when you take something from the stomach, when you take something from the GI and you bring it to the liver, listen guys, the liver, on top of everything else the liver is doing, the liver has this thing called the first pass effect. So you ready? How many times have you spent $100 on medicine? How many times have you spent $100 on medicine? How many times have you guys spent $100 on medicine? Never? Never, never, never. All the time. I spend $100 on medicine all the time. Ready? 60% of it, $60, I literally shit down the toilet. Y'all just hear me? I shit $60 down the toilet. Every month. And that $100 I spend on medicines, I shit $60 of it down the toilet. First pass effect. You guys got me? I know it's vulgar. I like that. It's shock value. Shock value. Right? Remember, I'm trying to imprint this on your brain. You'll remember it, right? He said, man, Professor P said he shit $60? Damn, he must be a millionaire. He must be a millionaire. He takes every time he shits $60. I love it, man. I love it. I need to take this shit out on the road. But guys, it's the truth. So anything that you consume in the way of anything, it goes all to the liver first. And the liver will take 60% of it, any drug that you would consume, and put it right back out there into the gastrointestinal system, through the gallbladder. So the liver's real main job is to do what? To detoxify. That's its main job. Separate of making coagulation factors, separate of all the other things like making albumin, and all the other things that we've been talking about. Now you hear me talking about the liver's main job is to detoxify. Separately, it's also a site of lymphatic drainage. So that means there's lymphoid cells there. Spleen is also lymphatic in origin, remember, because hematopoietic stem cells developed there. There were both sites of hematopoiesis at one point in embryological development. Yes? Guys, you see? There is a method to my madness. I am mad, no doubt. I do not deny that whatsoever. Yes.
No, I just had a question. So vitamin B12 and all the other ones leave via the hepatic portal or lacteals?
No, they get to the liver via hepatic portal. That's what I'm trying to tell you. They don't get the liver unless the hepatic portal vein is good. So if you got a problem with your hepatic portal vein, guys, are you going to have problems with digestion? Are you having problems feeding your liver and then your liver feeding your organs? Because that's what's going on. Huh? The liver gets it first because the liver decides who gives what. And the one person who's carte blanche is the brain. Glucose has this permissive effect with liver has this permissive effect when it comes to glucose. It needs to leave a certain amount in blood, always. That's what's the level of glucose in the blood necessary for proper brain function, guys? What's the normal glucose level in blood? Anyone?
81.5.
80 to 110. 120, they're now considered diabetic. Or borderline, you got issues. It used to be 120. It used to be 80 to 120. It's kind of the same as the pressures. Then they said, well, 120 is too high. When you start seeing these HB1ACs, what happens is when this is the research that we did with the honor students here at Miami-Dade. We just published a paper. I was involved in educating students on this. So when excess glucose flows around the bloodstream, it's got a couple things it's going to do, and none of them is good. It's naughty stuff that happens, man, when you got excess glucose flowing around the bloodstream and you're diabetic. Why, as a diabetic, would I have high levels of glucose in my bloodstream? Because I don't have insulin. Yes? And everyone understand that insulin opens the door to get glucose into cells other than in the brain. The brain's got an open door policy to glucose. Always. This is one of the reasons why when your glucose levels go too low, and when they go too high, you follow? So your brain always open door policy with glucose. Always. Liver's main job is to make sure brain's got 80 to 110 in the blood. You understand? And it'll elicit help by the what? By the pancreas to do so. Does everyone agree? Because the pancreas isn't storing glucagon, is it? No. Who's storing glucagon? Liver and muscle. Do everyone understand? When's your test?
Next.
Okay. So we still got time. Good. Because I'm teetering on metabolism right now. Do you understand? We said, wait, we need to metabolize glucose. One, we need to get the glucose there. Yeah? That's what the cardiovascular system job is. But what organ is involved in making sure that the sugar levels stay the way they need to? It's a combination of the liver and the pancreas together. Because the pancreas doesn't store sugar, the liver does. So if the sugar levels need to be raised, then you better believe the pancreas is going to call upon the liver to do so. You understand? Muscle isn't going to want to give it its glycogen supplies. It's glycogen stores. It's glycogen stores, which is its glucose supplies. It only does that in starvation. All right? So when you start starving yourself, well, a lot of things starts happening. And you start digesting muscle too. Huh? And it's a little of everything. Because guess what? Your liver don't want to let go of those glycogen stores because it knows it has to pay two people as long as it's working. The brain and the kidneys. Did everybody hear me? Because the brain and the kidneys need glucose. The heart preferentially uses fats. And again, this is the reason why exercise is beneficial. Get your heart rate up, you burn the fat on your body. Why? Because heart preferentially uses fatty acids. This is why your HDLs go up and your LDLs go down. When you do cardiovascular exercise regularly. Guys, it's common sense. At least for some. Right? Mad scientists. Right? That's, what was that? I forget the name of that movie. Any questions, guys, on this? Any questions at all? Now listen. Once I didn't talk about, so I did the fatty acids. I said glucose comes in. So so here's the thing. There are some glucose molecules, right? That when arranged, we don't have enzymes to break them down. You understand? Which means they stay and they'll move into the fecal material. And because they're glucose molecules, which are nothing more than polyalcohols, then they'll draw water out. Guys, this is why you should be eating plants. Because plants, this is why I don't want to hear this nonsense, I swear. Next person who tells me on the Atkins diet, I'm going to slap them. Right? I'm not going to eat any carbohydrates. Yeah, really? Good luck with that. Because you're going to cause yourself constipation too, on top of everything else. Because when you eat carbohydrates, you're eating a combination of simple sugars with complex carbs, and some of those complex carbs you can't break down. So they stay in the GI, absorb water, and allow you to poop normally. You don't eat them? Guess what? Now you're at risk for other issues. You get too much, you eat too much protein, especially protein that's been cured and smoked. The nitrogens in it will increase your risk for epithelial cancer. Keep eating those hot dogs, that bacon, and everything else. Oh, I love me some bacon. Oh,
That's keto diet, right? Something like that?
keto diet. Keto's yeah, you don't protein, just protein. Protein, don't eat carbohydrates. Okay.
Is bread bad for you?
No, you gotta eat whole grain breads, but it's gotta be a balanced diet. It's gotta be balanced diet. It's gotta be a balanced diet. People keep saying, I'm going to diet. You don't go to diet. Balanced diet, start exercising. That's it.
But for you, what would be a balanced diet?
A balanced diet would be based on your weight, your age, how much you should be eating in terms of protein. Go on to the National Science Foundation, NSF, or National Institute of Health, and type in a balanced diet for an adult. See what it says. And they give you a formula, show you how to calculate how much you should be eating of each of these necessary things to sustain your body weight. If you're trying to lose weight, then you got to cut it down a little. It doesn't have to be drastic. It's just 10, 20, 30 calories a day. And that adds up, man, in 30 days, 60 days, 90 days. It doesn't take a whole great lot of change, just a small amount of change. You know? Don't eat that candy bar every day. Eat it every other day. Eat it every 3 days. Eat it once a week only. You follow? You'd be surprised. Drink more water. Don't get me started. Don't get me started.